Hi, we're going to talk about 2016 AP Calculus AB exam question number 6. So the question here says that we have two functions f and g that have continuous second derivatives. We have a table of selected values of x that is given to us right here. We have values for f, f prime, g, and g prime. So we need to do in question A, we have function k that's defined as f of g of x. And we need to write an equation of the tangent line at x equals 3. So as we remember, when we're finding equations of tangent lines, we need the point and the slope. So let's find the point first. So our x value is 3. So for part A, k of 3 is going to be f of g of 3, right? And this is a composite function, so we're going to start by finding g of 3 first, because it's inside. G of 3 is 6, so it's going to be f of 6. And now we need to find f of 6 using the table. f6, the value is 4. Our point is 3, 4. We need the slope. The slope will be the derivative, so we need to find k prime of x. This is a composite function here. So to find the derivative here, we're going to need to use the chain rule. So it's going to be f prime of g of x times g prime of x. And then we're going to substitute 3 in for x. So k prime of 3 will be f prime of g of 3 times g prime of 3. And we're going to need the table again to find all this. So let's start there. G of 3, it's inside. G of 3 is 6, where we did it earlier. So it's going to be f prime of 6. G prime of 3, g prime of 3 is 2. We need to evaluate f prime of 6. So f prime of 6 is 5. 5 times 2 gives us 10. And that is the slope of the tangent line. We got the point right there. We got the slope. We're going to use point-slope form. Write the equation. Y minus 4 equals 10. X minus 3. And that takes care of part A. Let's take a look at part B. Part B has another function h of x, which is defined as g of x over f of x. And we need to find h prime of 1. So we need to differentiate the function that is a quotient of two other functions, and we're going to have to use the quotient rule. So let's do that first, and we'll come back to this. So for part B, h prime of x, according to the quotient rule, will be g prime of x times f of x minus g of x times f prime of x all over f of x squared. So now we're going to do this at 1. So h prime of 1 will be, and now we need the table to pull all these values from there. Put it here so we can see it. So it's going to be g prime of 1 times f of 1 minus g of 1 times f prime of 1 all over f of 1 squared. Now we can go back to the table and pull all these values from the table. So h prime of 1 will be g prime of 1. G prime of 1 is 8. F of 1. F of 1 is negative 6. G of 1 is 2. F prime of 1 is 3. And f of 1, as we already know, is negative 6 squared. Since this is a free response question, you do not have to simplify anything after this. You can leave it like that, but we want to try to make our math teachers proud, and we are going to actually evaluate this. This is negative 48 minus 6 divided by 36, which is negative 54 divided by 36. They both can be divided by 18, and the answer is negative 3/2. And that is the answer for part B. And one last thing left here, part C, which is a problem where you're going to have to use the fundamental theorem of calculus. Depending on your textbook, it may be the first part or the second part, but you have to do the integral from 1 to 3 of f double prime of 2x. So let's talk about how you do this. I'm going to rewrite that. We do need to come back to the table once we are done, but I'm going to do it in just a little bit. So part C, we have the integral from 1 to 3 of f double prime of 2x dx. So let's take a look at this first. So we have an integral of a function that is a double derivative of f of 2x. First of all, the integral and one of the derivatives will kind of sort of cancel each other. That's not entirely accurate, but it works as a shortcut. So we're going to get here, but, oh, and another thing is, but when you integrate this, this is 2x here as the argument of f double prime. So if you try to use chain rule here, this will result in giving you 1/2. So what we're supposed to get is 1/2 times f prime of 2x evaluated from 1 to 3. And now we go ahead and perform the process that we always do at this point. 1/2 times, substitute 3 in here, so it's going to be f prime of 2 times 3, and then minus, and substitute 1, f prime of 2 times 1, which gives us 1/2 of f prime of 6 minus f prime of 2. And we need to come back to the table of values. F prime of 6 is 5. I'm going to jot here that it's 5. F prime of 2 is negative 2. So all we need to do now is substitute that. So it's 1/2. 5 minus negative 2, which is going to give us, that's 7/7. And that is the answer for that. Have any questions? Put them in the comments. I hope this helps.